Hello friends, welcome to Tech Greens. Today we're going to discuss the difference between three of the major storage formats provided in the Hadoop ecosystem, and those are Parquet versus Avro versus ORC. So friends, let's see how these three formats are different and what are their specific use cases. So first let's discuss about the Parquet storage format. It's a column-oriented storage format so that the data is stored column-wise, which means that all the data for columns is stored adjacent to each other. Now the second advantage that we get with the columnar-oriented storage is that compression is much more effective, and we get a better compression ratio because data of same type, that is the data of one column, is stored together, and hence it results in better compression. In terms of schema evolution, Parquet is a little expensive because we need to merge the schema across multiple files. As you are aware that whenever we process Parquet files, it results in multiple outputs of each task. So that's why if there is any schema evolution, we need to merge those files across, and that's why schema evolution here is a little expensive. One of the excellent use cases for Parquet is where we have data processing of the nature which is read heavy, because we can select the specific columns as the underlying storage format is column oriented. Uh, Excellent with data consumption on the selected columns out of the bigger set of columns available in the underlying file system. One of the highlights of Parquet is it works excellent with the Spark systems, as there is a vectorized reader for Parquet file formats, right? Now let's see what is an Avro format. Avro, folks, is a row-oriented storage format. In Avro, schema is stored as a JSON file within the file along with the binary data, which makes schema evolution excellent with every file formats. But at the same time, as it's a row-oriented storage format, write operations are much more effective compared to read operations. That's why it's ideal for write-heavy kind of data operation scenarios. It is excellent when we have to consume the entire row and process the entire row. At the same time, one another highlight of Avro format is it is also a serialization and an RPC framework, so that it can be passed and over the wire across different nodes in the cluster. Okay. Now let's see what is ORC format. ORC format stands for Optimized Row Columnar File Format. It is also a column-oriented storage format. Schema in the ORC files is stored in the footer, and schema evolution in the ORC file is actually limited to adding only new columns. The deletion, the renaming of the columns is not supported with the ORC file formats. As it is a column oriented system, it is ideal for read heavy operations, as you can select the specific columns as they are columnar in nature. It is excellent for data consumption where you have to work with selective columns. Uh, Again, it works excellent with the Hive system, as there is a vectorized reader for ORC file systems. So as it is primarily developed by the Hortonworks, and they promote Hive processing systems, and it was primarily built for an Hive systems, where they have added a vectorized index-based reader for ORC file systems. That's why it works excellent with Hive. Now let's look at the comparison what we have discussed in the previous slides. Let's see the first parameter, which is schema evolution. If we talk about Avro, excellent schema evolution, as schema is stored in the JSON format within the file. So if there is any addition deletion of the columns, JSON can be updated pretty fast. In terms of Parquet, schema evolution is a little expensive, as we discussed that it needs to merge different files across. For ORC file systems, schema evolution is limited to adding new columns, or in some cases maybe changing the data types to the bigger uh, bigger data types, like from int to big int. That kind of schema evolution is supported in ORC. Next parameter is compression. With Avro, compression is not that excellent. Reason being, it's a row-oriented format and the entire row are stored together. When we store the entire rows adjacent to each other, then it becomes a heterogeneous data across columns, and thus we do not achieve better compression ratio. While if we talk about Parquet, Parquet is a columnar oriented and the same type of data resides together, hence we can achieve better compression ratios, and at the same time snappy algorithm of compression work best with Parquet. In terms of ORC, it is also columnar oriented, so here also compression is best, and the algorithm which works excellent with ORC file formats is zlib. In terms of splittability, that means how easy it is to split a file for random read and access. Uh, so all these files work with distributed systems, so they are splittable in nature. But if we talk about Avro and Parquet, they are partially splittable, while ORC, because it stores the data uh, within a column of a particular row as blocks, it is fully splittable. In terms of what is their underlying orientation for storage, Avro is row oriented, Parquet is column oriented, ORC is also column oriented storage formats. In terms of read and write accessibilities, Avro is an ideal for the use cases where we have write heavy data operations. For both Parquet and ORC, it is meant for read heavy operations as we can work with selected columns. Uh, the optimized performance engines where these formats work best are Avro primarily works best with the Kafka systems. Parquet is an excellent and ideal choice for Spark, while ORC work best with Hive kind of systems. So guys, that's it in my video to have a comprehensive comparison between three of the major storage formats, which are Parquet, Avro, and ORC. So guys, that's it. That's all for today. Thanks for watching. Have a great day ahead. Bye bye.